Hey everybody, Mr. Piercy here, and we're going to be looking in this video some properties of conditional statements. A conditional statement is generally something that's going to be written as an if-then statement. So we start off by saying, well, if I do this, then this thing happens. And it's a very common type of logic statement that's used, not just in geometry, but in a lot of situations. I mean, probably we've all been in the situation where we had to ask, a parent or a friend or something like that, some favor, and they say, well, if I can get the day off, then we can go to do this thing, or if you get your room cleaned, then you can have this whatever that you're asking for. So that's what a conditional statement is. It's something that's written in an if-then format. One of the things, so in the definition that I'm giving you here for the if-then form, it's a conditional statement. I'm just giving you an example, but I want you to pay particular. I don't want my highlighter. Why don't I have my highlighter on? I want you to pay particular attention to. Here we go. Things look like they're cooking now. Let's pick something other than red here. If P, then Q. P is often used to represent the hypothesis of a conditional statement, and the hypothesis of the conditional statement is the if part of the statement, and the Q is the conclusion of the conditional statement, or the then portion of a conditional statement. So the P and Q thing is kind of a generic way, because we can have an infinite number of conditional statements, and the hypothesis and conclusions could be anything. They could be anything. So in order to simplify it to a generality, we just say P for hypothesis, Q for conclusion, kind of like we just use X a lot to represent a variable in an algebra equation. So now when we talk about a negation, a negation is, again, something that we do is as a logical statement, or as a part of a logical statement, where I say, well, if I don't get paid today, or if I don't get the day off, we're negating something, where we add a not part to it, something that's not something, or we're not doing something. And if you see the single wavy line that we have here, that's the symbol for us negating something. So the symbol here that has the little wavy line with the P, we say that that's not something. So in the example that I have in the if-then statement says, if I get paid today, that's the hypothesis. Well, if I negate the hypothesis, I would say, if I do not get paid today. That's how we would negate it. So if you need to, pause the video and get the rest of the definitions copied down, but we're going to go ahead and move on, because we have quite a lot of them. Here we're talking about a converse. Now, the next three vocabulary terms that we see here, converse, inverse, and contrapositive, those are all different types of conditional statements, where I take the original conditional statement, the one that was given to me in the if-then format, and then I'm going to do some things to it. The converse statement is going to reverse the order of the hypothesis and conclusion, where the inverse statement keeps them in the same order, but it negates the hypothesis and conclusion. And the contrapositive is going to do both at the same time. It's going to reverse the order of the hypothesis and conclusion and negate them at the same time. So we're going to be practicing these three, we're going to be practicing writing these three types of conditional statements, where we're given a conditional statement and then we're going to write the converse, inverse, and contrapositive based on what these definitions are telling us to do. Now, the equivalent statements are not something that we're going to be doing too much of right now, but equivalent statements are generally going to be two statements that are either both true or both false, and they're going to be used to write biconditional statements, where I'm going to take two statements and kind of merge them together into one statement, where like the beginning or the end is separated by the words if and only if. So again, take the time, go ahead and pause the video as you need to make sure you get all the vocabulary copied down, but we're going to go ahead and move on here. Now looking at the definition, or looking at what we have here, what we're given is we're just given a statement, and it's asking us to take this statement and write it as a conditional statement, as an if-then statement. Usually, what we're going to do is we're going to separate whatever has been given to us into a hypothesis and a conclusion, and usually the hypothesis is what is given to us first, and the conclusion, obviously, what's given to us second. So what I'm doing at the bottom is I'm highlighting the word vertebrates and I'm highlighting the word backbone. And what I'm doing here, somewhere, is the hypothesis is generally what's going to be given first, followed by the conclusion. So the hypothesis is what we're looking at for my vertebrates. So the way that I'm going to take that is and write it in an if-then format is I'm going to say if an animal, and it's okay to add some things to a conditional statement to make it make sense. I don't want to say if vertebrates, then a backbone, because that statement doesn't make any sense. But if I say if an animal is a vertebrate, then that animal has a backbone, and that's kind of how I'm stating my conditional statement. It's okay to include a few extra words to have a sentence actually make sense. Okay, so it's not something that we have to take exactly what was given to us, because if I made the statement, if vertebrates, then a backbone, that statement makes no sense at all. So by including the words, if an animal is a vertebrate, that makes more sense as a sentence. Okay, so here, go ahead and try practicing. Take these statements that are given to you and write them as a conditional statement in an if-then form. Okay, so go ahead and pause the video and answer these two questions. Write them in as a conditional statement in if-then form, and when you have your statements written, go ahead and hit play again and look at your answers and compare them how mine are. Okay, so I'm assuming that we have our stuff, finished. We have our good statements. Looking at it again, I'm looking at the first statement that says all triangles have three sides. So the beginning part of that statement is talking about a figure that's called a triangle. And then it ends with saying something that it has three sides. So the way that I'm looking at this is writing it as a conditional statement is I'm going to say, if a figure is a triangle, then it has three sides. So the words a figure obviously is not given to us in the original statement, but by including them, we definitely have something that sounds like an actual sentence now, rather than just kind of a sentence fragment. So the second one says when x is equal to 2, x squared must be equal to 4. So the beginning part, x is equal to 2, must be the hypothesis, and the conclusion, x squared equals 4, is the conclusion. So here I'm going to say if x is equal to 2, then x squared is equal to 4. So in this case, we didn't really have to include very much to make it into a good conditional statement, but that's what we have for our answers for those two examples. Now moving on, this is where we're going to start practicing writing our conditional statements, meaning we're going to start with a statement and we're going to take the statement and we're going to turn that statement into a conditional statement written in if-then form. Now the converse, inverse, and contrapositive are also a type of conditional statement. It's just that we're changing maybe where the hypothesis and conclusion are written, and or we're going to negate something, meaning that we're going to include the word not somewhere in our statement. So starting off with the statement, Olympians are athletes. That's what we're given. So Olympians are athletes. So the first thing that we're talking about is Olympians. So that is what I'm going to make as my hypothesis, and then athletes is going to be part of my conclusion. So my statement, my conditional statement, is that if you are an Olympian, then you are an athlete. Now the next thing it's asking us to do is decide whether that statement is true or false. Well, if you are an Olympian, then yes, you are an athlete. You're competing for a silver medal or a bronze medal or hopefully a gold medal. You know, we're all wanting to be Michael Phelps now. So if you are an Olympian, then you are an athlete. That's true because Olympians are athletes. Now, the converse statement is where I'm going to take my conditional statement. I'm going to take the if-then that we just wrote, and I'm going to rewrite it where I reverse the order of the hypothesis and conclusion. So the way that I write that is I'm going to say, if you are an athlete, then you are an Olympian. So between the first statement and the converse statement, all we did was reverse the order of the parts. Now, the converse statement in this case is true. If you are an athlete, then you are an Olympian. Because there's a lot of people that are athletes, but they don't compete in the Olympics. The inverse statement is when I'm going to take the conditional statement. Where I'm going to take the if you are an Olympian, then you are an athlete statement, and I'm going to write it in such a way that I'm negating the hypothesis and conclusion. So here I'm going to say if you are not an Olympian, then you are not an athlete. Okay, and that's how we write the inverse. And that statement is also false because even if you're not an Olympian, you can still be an athlete. Now, the contrapositive is the final way that we generally write conditional statements. Okay, here the contrapositive is going to flip the order of the hypothesis and conclusion like we did in the converse, and we're going to include the negation like we did in the inverse. So essentially, if I reverse the order of the inverse that I have now, I will have my contrapositive. So my contrapositive says, if you are not an athlete, then you are not an Olympian, which is a pretty fair statement. If I, a math teacher who is not an athlete, I am definitely not going to be competing in the Summer or Winter Olympics. Maybe the Math Olympics, if that's ever a thing. But that's how we're going to write our converse, inverse, and contrapositive statements from a given conditional statement. Now here, this is, definition of perpendicular lines. I think pretty much everybody knows this. It's just going to be two angles that or two lines that intersect to form a right angle. So what we want to be able to do here is, use some information about what a perpendicular line is to make some conclusions about some things. Now, to be fair, I don't really consider this to be straightforward, what perpendicular lines are or are not, because we're just kind of using the definition of what these things are, but it's also going to be based off of a basic geometry principle that, I use in class a lot that says you can't simply say something is or is not something because of the way it looks. You can't say two lines are perpendicular because they look like they're perpendicular. There must be something that justifies you saying that, meaning that I can show that I have angles that are 90 degrees in measurement, or that I've been given in something in a figure that shows that I have a right angle, or I'm told something is a square, or something is already perpendicular. We have to be given some kind of information. We can't make any assumptions about anything. So looking at part A, where it says line AC is perpendicular to line BD. Well, AC, if I look at it, and BD, they're intersecting, and they're showing me with the right angle symbol that there's a right angle there. So because they have a right angle, it must mean that they're perpendicular. So I'd say, yes, that is a true statement because I have a right angle. So that means that the lines are perpendicular to each other. Now, looking at the next one, part B, we're saying angle AED. So here's angle AED. And then we're talking about angle BEC. So here's angle BEC. We're trying to say that those two angles are a linear pair. Well, based on the definition of a linear pair of angles are going to be angles that are adjacent to each other whose non-common sides are going to form opposite rays, meaning that they have to form opposite sides. So here I have angle 1, here I have angle 2. The side here that's common between angle 1 and angle 2, and the non-common sides, let me go back here, would be this side here and this side here. The non-common sides have to form a line. And that's not what we see in this diagram. They're not showing us that, first of all, they're not adjacent. Second, they don't have sides that form a line. So these are not going to be a linear pair. The best way to describe those two angles would in fact be a perpendicular line. And now that I'm thinking about it, there's something that I want to go back to real quick because I forgot I included this information. We're going to come back here to this part of our notes. I'm going to go ahead and pop these back up here. We should already have them written down, but there's something I added here that I forgot to mention earlier. And I want you guys to recognize here the conditional statement was true and the contrapositive statement was true, while the converse statement was false and the inverse was also false. That's not really a coincidence. When we're talking about conditional statements, our given statement, the original one that's in if-then form, the one that we generally think of as our conditional statement, the conditional statement and the contrapositive will always have the same truth value, meaning if one is true, the other is true. If one is false, the other is false. Same thing with the converse and the inverse. If the converse is true, the inverse must be true. If the inverse is false, the converse also must be false. So I apologize for missing that earlier, but I wanted to go back before I went too far ahead. Just that's not something that's part of our notes, but I do think it is an important connection when we're talking about our conditional statements. So the last thing that we're going to be talking about here really is how do we do a biconditional? A biconditional is often something that we use to determine whether something is going to make a good definition in geometry, meaning that it should be reversible. If I make a statement and I can reverse the statement and it is still true, then that is something that we can use to write a biconditional, or we could use that as a good definition. So the definition that we have here says, if two lines lie in the same plane and do not intersect, then they are parallel. Okay, so taking that statement at its value as far as a conditional statement, I would say the definition is true. So the converse, if I turn the converse around, or if I turn the conditional statement around as the converse and I write that, I'm going to get, if two lines are parallel, then the lines lie in the same plane and do not intersect. Well, the converse in this case is also true. So because the conditional statement that was given to me is true and its converse is also true, we can take those two statements and combine them into one, and we call that a biconditional statement. So the way that I write that is I say two lines are parallel if and only if they lie in the same plane and do not intersect. So that's how we're taking the two parts of the true conditional statement and a true converse statement, combining them into one biconditional statement where they're separate, where the parts are separated by the words if and only if. So the last part here is going to take you a little bit of time because it's asking you to write several statements. It's asking you to write a conditional statement along with the converse, inverse, and contrapositive of that conditional statement. And that can take a little bit of time. But it's really important to make sure that you can recognize what those statements are when you see them, or write one based off of the vocabulary term that I'm giving you. So go ahead and pause the video now and go ahead and answer questions 3, 4, and 5, because we just have those last few questions here and then you guys are going to be done. So go ahead and pause the video, answer questions 3, 4, and 5, and when you have your answers on your paper, go ahead and come back to the video, hit play, and compare your answers and see how they look with mine. All right, so hopefully we have our good, we have some answers here for questions 3, 4, and 5. Based on what I'm seeing in the question, we have the statement squares are rectangles. So the first thing I'm going to do is write a conditional statement about that. This says if a figure is a square, then the figure is a rectangle. So I'm going to go ahead and write that down. And that's what I have in red. That's my conditional statement. Well, my conditional statement is true. If a figure is a square, then the figure is a rectangle. That's true, because every square is also a rectangle. So the converse is when we flip the order of those. So I get if a figure is a rectangle, then the figure is a square, which is false, because not every rectangle is a square. The inverse is where I'm going to negate the hypothesis and conclusion of the conditional statement. So I wind up with if a figure is not a square, then the figure is not a, and that should say rectangle. That's a typo. So glad I saw that. That should say rectangle. And the last one, contrapositive, is when I flip the order and do the negation at the same time. So the contrapositive says, if a figure is not a rectangle, then the figure is not a square, which would be true. So those are our four conditional statements that we have: the original if-then statement, and then followed by the converse, inverse, and contrapositive. So here, part A and B tell whether these things are true based off of the definitions that we know about them. Angle GLK and JLK are supplementary. That is true because they are a linear pair, and linear pairs are supplementary. GJ and HK, are they perpendicular? In this case, no, they're not, because there's simply not enough information. I don't know if those are drawn to look perpendicular. Just looking at them, they don't really look perpendicular, but that doesn't mean anything because the figure could be purposely drawn not to be to scale. I would have to have something that says, like I have a right angle symbol there or something, but right now there's not enough information for me to say that that figure is perpendicular or not. Now, moving on to the last statement here, write a statement as a biconditional. So we have our statement: if a student is a boy, he will be in group A. So we reversed it and say if a student is in group A, then the student must be a boy. Now we're going to, for the time being, we have to kind of think, well, those statements are probably true. If a statement is a boy, he's going to be put in group A. Okay, we'll take that as true. So if I reverse it, the converse in this case must also be true. So the way that I'm going to write this as a biconditional somewhere, there we go. A student is in group A if and only if the student is a boy. So that's how we would write our biconditional in this case. Not really the greatest example. I would have liked to have maybe had something about isosceles triangles or something along those lines, but still not a bad example of how you write a conditional or a biconditional statement rather. So that's going to call it, we're going to call it quits here for what we're talking about as far as our conditional statements. How we write a conditional statement, meaning, it's an if-then form where the hypothesis is the if part, the conclusion is then, and then we reverse the order for the converse, negate the hypothesis and conclusion for the inverse, and then do both for the contrapositive. And then if I have a true converse and a true conditional statement, we can use that information to write a biconditional and so on. But that's going to call it quits for today, ladies and gentlemen. If you have any questions about anything you've seen in this video, by all means, please let me know what they are, and I'll be happy to help you out. Until next time, thanks for watching and take care.